Okay, that should be working. So let's continue, and let's take a look on the Xstring project, and let's see some of your implementations for those functions. So last time we taken a look on compare. A substring. Maybe let's take a look on one of the more complex assignments. The update of XList from a single linked list to a doubly linked list. Who of you would like to show their solution? Okay.
Okay. Okay. So like a single linked list was where we just appended one end, right? And the double linked is where we appended both ends. I'm just trying to remember what it was.
Yes.
Yes. Okay. Very nice. Connect. I forgot again which one the IP address was. I think it was 6858. Is that possible? I think that's the one we used last time.
I think it will be this one. Was the chat window? Chat. I think it was this one.
Oh yes. Okay. Okay, I'm having trouble connecting.
Is it not working?
It gives me a timeout error when trying to connect.
Let me try. Yeah. Okay, try again.
Yes, now it's working. Yes. Okay. Still to find a solution. Haven't found yet. So essentially, we just had to do the prepend function, right?
It's a bit more convoluted because both append functions must update both values correctly, and I think we also had a remove function somewhere.
So,
Oh, we didn't add a remove function. That's an oversight. Then we should add that today.
Okay. Okay. Oh, sorry, I still need some time to open my solution because I can't quite remember how to do it. Okay. Okay, let's see. Okay. So just okay. What do we have? Okay, we have yes. So we certainly have to do the prepend
Yes.
function. I'd say we do it first. Is this the header? Yes. Or in this? Okay, yes.
In this X files, we always
Oh,
only
we
have
always
the
work in
header
the header
because
okay.
it's a template. Yes.
Yeah. Okay. So how did I do this? So I created a new entry. And a new pointer to the new entry. Okay, interesting. But I think I remember we worked with these like pointers to pointers sometime in these X list. Okay. Oh, okay. It's lagging. Can you still hear me?
Yes, I hear you.
Okay. Oh, there you go. Okay. Okay. It just says my connection is a bit unstable, but
Okay.
I can now write again. And one more called PS. Okay. Let's see. Let's do it again. Okay, so we do so we need to redefine a couple of things, I guess. So the previous one becomes the pointer to the new one. Then our pointer to the data restoring p new. So p next becomes the head. So okay. I'm sorry, I wish I could explain this in a bit more detail, but to me right now it just sounds just reads like a bunch of pointer reassignments that I did. But that's all I have. Let's see if this makes sense. So we're trying to prepend. So previously we've always appended at the tail, right? And now we're trying to append at the head as well. So we're doing we need to create a pointer pointing to the new entry, and then we need to put the current head into the p So the current p head becomes the p previous or p next. Oh, I'm so confused. I remember I was very confused about this. I should have added more comments to my code because I have no comments. And now I'm confused. Uh, does it make sense to you? I know
It's
I
a
tried
bit
it on some.
convoluted,
It's
but
a bit
was it
convoluted,
working? Did
yes.
you test whether it
It
works?
I did some. I mean, I can quickly share my screen. I made some.
But let's see. Okay,
I
so
always
we have
wrote
a
some
project of
extended like
new. Is a new.
examples.
We make next new. We make data. We make next the old head, and the new head is new. Now that should be right. That should do what it's doing it in a very convoluted way,
Okay. Yeah.
but it should work.
Mm-hmm.
So,
And then what else do we have to
well, the main thing
redo?
about doing it doubly linked is to have this tail variable here uncommented and to set it also correctly. And the thing is that if we would have the tail variable, then we can make the append also much more simple.
Okay. Yes.
And the challenge is that if you are inserting, then you need to always update both head and tail variables
Yeah.
accordingly, or rather the internal. I mean, there is a second one that you also need to enable, not just the tail, but in the object itself, the preview one, which is
Yeah.
also
I
important
I
to
think I
have a
remember
doubly
that.
linked list. So
Okay. So, but first we comment out the tails because now we have a tail. Wait. Oh. Well, we're appending to the head, but now the new variable is the tail that we previously didn't need. Does it make sense? Why am I confused by this? Uh, so I've added a bunch of new lines here. Yeah, okay. What is that? The equal operator, the assignment operator. Yeah, sure, because we need to assign the new. So maybe I'll put some comments here and then I add what I've added here
well, I would
for a
first
new.
fix the append and prepend functions,
Okay.
and then do the more complex ones,
Mhm.
and test it like really simple. So first, just do the basics, and then test
Yeah.
with the iterator whether we are inserting at the right positions.
Hmm. I'll make some comments where I'm doing my edits so
Okay.
that it's easier to fix afterwards. Oh wait, no. Yes, okay. Here I'm defining something. Uh, I'm calling this the previous because it holds the pointer to the previous entry, which is we first set up the null pointer, and then this I use to so that we can have a previous append tail. Um, and in the for loop, yeah, okay, yeah, can comment this out a bit. Okay, okay. So, what's happening here? Yeah, okay. So, what do we do here? We go to so we're having a loop over. Jesus. I don't know. I mean, maybe anyone else has a more clear idea of what they did with that specific assignment. I was just because I just looking at my code and I saw that I made a bunch of examples to see if it works, and it seemed to be working. So I thought maybe I could implement it here. But
Okay,
looking
anyone
at these
else want to
pointers now,
try
I'm
the doubly linked
very
list?
confused.
I can try.
Okay.
I mean, so maybe should I remove all of my edits or
Yeah, I can do that. I just
yeah,
keep Control C long enough.
yes. Ah, damn.
Okay.
Can you send the new IP? Because I don't think
It's in the chat.
Is it? Oh, sorry. So, okay. So this we need, and this we need. Right. Oh, this we need, and this is the to do. Right. Yes. So let me just find it. Right, and then we have two cases. Either or we have something already in the list, or the list is empty.
Mm-hmm.
And if it's empty, then we should set the tail. Is this not? Oh yes, it's just fine. This should be new entry, and then we should also always set the head. And then it's that if we already have something, then we set new entry to, or new entry P next. Why does it not autocomplete?
Sometimes doesn't.
And P head. Like this. I think this should be it. And then we can do, well, I think this append can be rewritten similarly.
Yes. So once we have the tail variable, then append can be much more simple.
Yeah. I just comment this out. Okay. And I will just copy what I already wrote.
Mm-hmm.
Because it's the same as below. There we go. I think this is it. Or?
Could be. Let's test it.
Yeah. Where's our main function? It's here. So I already have a test case. Oh, it's formatted quite funny when I copy paste. These are not implemented. Wait, what's this? Oh, yes. There we go. So create an empty list, and then we try to append 1, 2, 3, and then we prepend 0, so we should have 0, 1, 2, 3.
Mm-hmm.
Oh no. What's wrong?
You forgot the new
Yes.
keyword.
Yeah, there we go. Sorry. To my... Here we go. So 0, 1, 2, 3, and 3, 2, 1, 0.
Okay. Good. That worked great. So what we missed to add to this function, to this class, was an ability to remove entries that were once added. Would you like to add this functionality?
I can try.
Okay.
If
So
no one else wants to do it, I can try.
just let me have the mouse for a second.
Yeah, of course.
So let's see. We will do it simple. We will just make it such that if you have a pointer to an element, then you can pass this pointer here. So we will make something like something like this. And this element should then be removed from the list.
Yes.
It's not very difficult. You only need to combine the combine the pointers correctly, and then you can delete the element in the middle. The only thing that makes it a bit complicated is that you need to handle the edge cases where the element is the first or the last in the list. So where you then need to update not just the adjacent elements, but instead the heads and tails pointers themselves.
Yeah, well, so this P2 remove will so okay, so this entry, will this always, so just not that this is correct, but if I do this, then this will always delete the correct entry.
Yes.
It will always find the right entry.
It will delete the right entry, but then the whole list will be broken because the pointers that remained in the list will be pointing to this entry which does no longer exist, so that would be very bad.
Yeah, so let's not do this. But could you do that and then just to fix the pointers afterwards, or is that very convoluted?
Well, you need to know the pointers which you want to fix, and to know them you need to still have them, and they are provided into remove in the pnext and ppref variables. So deleting the entry will be the last operation after it has been unlinked from the list.
Okay, so I should first unlink it from the list.
Yes.
Okay, I'm not so sure how I would do that. I would,
You basically just need to make the pointers that are in use point to the how to say it. They are currently pointing on the element, and you need just to make them point past the element to the one after it in both directions.
yes, but so let's just write some arbitrary entries. Let's say I want to remove this element, then I
Yes.
need it's
Then you
this
need to make
next.
two next point to 4. Yes.
Yes, and this needs
And
to point to
yes, exactly.
yes. But then first I need to okay, should I iterate all the way from here
No,
until I
you don't need
find
to iterate because you have a pointer to 2 and to 4 inside P inside P
you're
to
right.
remove.
You're right. You're right.
The only special cases are, as mentioned, that if the next or the pref pointer into remove is null, then it means that it is the first or the last entry or the only entry, in which case the pointers to be updated will not be the pointers it points to because it doesn't point anywhere, but instead the heads and tails pointers of the main object.
Right. So in this case, if I want to remove 4 or if I want to remove 3, then pnext will be 4 and okay, yeah.
Yeah.
So I guess I should store this in
Store this somewhere.
yeah. So oh, whoops. And then I set next. Wait. So So next. Oh wait. Let's do previous. Pnext equals next. Right, and then we need to handle the edge cases.
Exactly.
I guess I should do this here. So if next, or if not next. Okay, so if so if next is null pointer, then it means that we're here, and then this should just not be set. Okay, let's do this instead. If next, then like this. And previous. Wait. If next is null pointer, don't I assign null pointer to this one then? Doesn't that fix the edge cases? Or is the problem something else?
Well, it can be also that preview is null pointer, right? So you do the wrong test. You should swap them. So Yeah, and the other
What do
one
you
up.
Oh.
No, it was correct.
Oh.
Because if you have next, then you can assign next, and if you don't have next, then you need to assign MP tail instead of next. Because if prev was not tail, head, previous head, yeah. So else case makes the head. No. You have the MP head variable,
Yeah.
and then header should be previous, and in the other one it will be tail.
Okay. Right. Wait, so if there is no previous element, this means that we're the first in the list, and if we're the first in the list, then the tail should be
Wait,
the next element.
if there is no previous, then we swapped it. Then it should be head. Sorry. If that is no next, then tail. Yeah, that makes more sense. Yes. That should be correct.
Wait. If we're here, then previous will be null pointer. Then we will be here. And then we will set head to null pointer.
That is not correct. Yeah, right. Wait, let me think about it. So if we are in an edge case, right, we are removing. No, because now they are wrong. In line 128, we should assign next, and in line 121, we should assign preview.
Yeah, this makes more. Yeah, this makes sense.
Yeah.
Okay.
Then let's make a test case for it and see if it works.
That's okay. So I will just look at this. Remove this in the meantime, and I will do my list. Remove item. Cool. Oh, I need to remove. How does this work?
No. Currently it is a bit convoluted, so we can. I can make a test case for you.
Okay, sure.
So also let's move that down and print the list twice. Print the list twice in both directions. Wait.
Okay. Oh, you can control set back to when I.
Both is forward. Okay, so let's leave it like this for now. So we just take one of them. Then let's say we want to remove something from the middle. Or let's just put this in brackets so it's scoped, then it should be fine. So if we go 2 in the middle, then we should so we have append to 0. So we should have removed, if we go 2, the first is 0, then we should remove 3 if we do this. And then just feed this to that, and that should remove, wait. Is this const? This is const. Let's just not make it const for now. Okay. 0, 1. We remove 2. Now that makes sense. Yeah, that seemed to work.
We can try the edge case also.
Yes, so let's just move the last one. 0, 1, 2, and then let's try the other edge case. 1, 2, 3. Yeah, perfect. That works fine. That works very fine. Good. So the next string-related interesting task would be this assignment here. The iterator mechanism, as we have seen it in the C array. It's a bit more complex, but also very useful. Who would like to demonstrate that?
I can if no one else wants to.
Okay.
Let's see. Which homework was this?
28th of November.
Wait, in which this is in XList,
Mhm.
right? Yeah. Let me see if I can find my implementation. Wait. Was this I can't seem to find.
Let me take a look on the Moodle. Which number this was? No, but I didn't number them anyways. I just put the date. So
Wait, it might be this one.
uh,
Yeah, I found it.
okay.
Okay. Let me just put this on the public screen. So, okay. Where did I start with this? I guess here. So, oh, no. Okay, I will just copy this because I think it'll take too long to write.
Hmm?
Okay. Wait. I will just do this.
Copying and pasting over the VNC should work just fine.
Yeah, I was just looking to accept all of this spacing. Okay. Right, we need a couple of more things. So we need the app. Right. And then outside in I find this in protected.
Hmm?
I did oh wait, yes, no, outside here even. Wait, no, wait, give me 1 minute, 1 second. Ah, here. Ah, right, and then I had the get size because usize is private, I think. I think this was it, right? Okay, let's just take a look at what we have so far. Okay, so we have the struct, we have the equals operator,
Mm-hmm.
the plus plus operator, uh,
And you use index and you have the at function, okay.
and yes, and these are the
Okay, and let's take a look to the at function.
okay. So at index,
Okay.
let me okay, wait. This was the task was to analogous it how it's in array. Can I just say the
Yeah,
difference
so
here?
the idea
Oh,
was more that since the iterator does not allow you to access the index but always only the adjacent component, that you could use the next and the previous variables, and then you
Ah.
wouldn't need to iterate through the list, because this is quite inefficient. If you use the iterator
yeah,
to go
yeah,
through a very large list, then it will take forever, because it will always start at the beginning and then loop to the right index. And so the way an iterator for a linked list should work is that it would really exploit the ability of using both previous and next pointers, and then just always give you constant time when looking up the next element. Does anyone has an implementation like this?
I haven't gotten to that exercise. So.
Sorry?
I didn't do it.
Ah.
Yes, I find time.
Okay.
Maybe Oliver?
Then
I'm not completely sure. It was long ago.
you can check.
Now I started C-Line instead of Visual Studio.
Okay.
This was homework 7, right?
I did not
my
number them.
my code was in Xstring 5.
Yeah, that does not help.
Okay.
Because the folders in the zip files are not named.
Okay.
7, yes, homework 7 was
Okay.
it.
Yeah, I'm not completely sure. I think this would take too much time to read myself into what I did again.
Okay. then let me try. So
Wait,
let's see. So this part should be working. Then we have our iterator. Here we have the add functions. We have begin. Okay. So in principle, the iterator should just take head, and the end iterator should just take null. Maybe, we will see. But that sounds like a plan. Yeah, so here we add head. Head is head. This is okay. This is now it's okay. Operator. This well plus plus is then just head is equals head next. Plus plus is the same. Is equals just compares heads. Is unequals just as the opposite. Oops. And here we then have head. And wait, why is this the same? Oh, there we are. And this will be asterisk head. Yeah. Wait, it should be T. T is the type that should then not be head. That should be the data our head holds. Data. And the data will have a reference because data was. Don't have data. Where's data? T data. Yeah, that should be fine. And here we will have just data. Right, yo. Should be right. So form auto e is equals my list begin is ungleich end plus plus e data asterisk e. Maybe that's correct. Let's see. Ah, wait, we forgot something. Yeah, that's how it should be. And it's still not happy. What did we forget? Okay, get size apparently we did not have implemented, but we don't need it. And the semicolon is missing. Wait, what? Null is where's the constructor? Why would that not like null? That I'm not sure why it doesn't like null. It should always like null. It must be included somewhere where we don't have the right other include and I should add a print line so that we know where the new thing starts. One, two, three. Yeah, it works. So that's how this was supposed to work. And we could in principle also add a reverse iterator to iterate in the other direction. Reverse iterator. Wait, that was a bit too much. Although actually that is not quite wrong. We just wait, or was it even right? It even was right. We just called them rbegin and rend, rbegin and rend, and of course instead of head we will always now put in tail everywhere. And instead of next we'll go with preview. Pep preview. Wait, where am I? It's just those two anyways. Good, so let's go to main and then forward, backward or reverse. rbegin and rend, and let's run it. 3, 2, 1. Yes. That works great. And at this point we can also use the I, since it gives us, no, it only gives us the data. It only gives us the data. So to have full functionality, it would be nice to have a arrays an arrays instruction. We need to implement it twice for both directions. Yeah. So the arrays is specified it's gonna be const, I think. The arrays is specified such that it will remove the element which the iterator points to, and it will give us the next element. So it will give us a new iterator, so that we can keep going through the list when we have when we erased something. So let's go back to our main and let's comment out all of these. And here we will print forward, and then we will do some arrays. So we will just begin e plus plus my list arrays e. Okay. So first of all we need to make an iterator for the next thing. So arrays j is equals e plus plus j to j, so that we already are past the element that we want to kill, and then here we will just use remove of item, and I see we have some at somewhere. We don't want those since they are super inefficient. Add those remove. Right. So remove item. E punct. Yeah. We shouldn't call it head. We should call it something like current. Because it's not really. It's still not. It's not really head at the end. So mpeg. Yeah, that makes. And here we will also call it current and erase current, and here for this one we do the same. This one, in this one we call it tail. So here we'll also rename it to current. Right, and then we also make a reverse iterator erase. So this should work. Yeah. Okay, let's try. So 0, 1, 2, 3. 0, we deleted 1, 2, 3, and 3, 2, 0. Yeah. So erase works as well. Good. I mean, we could of course look for something even more convoluted, like an insert function. Remove item. Insert item to so append the data per where. So the idea of this function would be that we have some data we want to insert, and we have a pointer to an item, and what we want to do is we want to insert the element instead of the item and push the item once down. In principle, we should also want to have a function that does the opposite. So that we can insert before. That is fine. That is fine. Yeah, that should work fine. So if we specify the first element, then it will be inserted at the head. If we specify the last element, it will be inserted second to last. And then if we want to use this to insert it as last, we would specify as where null. Or we could do it the opposite way around, that if we specify where, and it will be actually inserted after it. But usually the semantics of insert is that it inserts at wherever we point the where to. So let's go with the first option. Does anyone of you want to try to implement that? It's not so difficult. It's like the append, just that, or like the prepend or append, just that it goes somewhere in the middle and you have a bit more edge cases. It's a bit more like the remove item, since you need to relink the links again.
I'm not sure if I will succeed, but I can try it,
Okay,
I guess.
let's try.
Nice. Okay, you said it must be a bit like the remove function, just the inverse, I guess.
Basically, we create a new element, and the creating of the new element we can copy from append, and then we just need to update the pointers correctly to insert it in the right place in our linked list.
Okay, where is the... there. No. Where was the insert method now? Ah, here.
Here.
Okay, so I create my new item.
You can copy the creation code from the append function.
Ah, yeah.
Just 2 lines, but saves a few seconds still. Now it's searching only in the text you have marked. You need to
Oh.
click outside for the thing
Thank
to
you.
search in the global scope.
Okay. Now, yeah. Now I get the previous one. Wait, I set it like this. The new entry dot previous must be the p-where dot previous
Mm,
because I'm inserting it
Mhm.
before.
yes.
Then
You are missing the error.
yeah. Then this one must be new entry
Yes.
and new entry p next is p-where.
Mm-hmm.
And now I have to find the object which came after P. Oh no, because then, yeah, I think this must be everything. Because the
No,
item
you need
after.
to update the other item. So if we copy this example here
Ah, yeah, I need. Yeah, yeah.
and we insert it, let's say here. No,
Ah, yeah, I need to
7.
update the previous and
You need to
the-
update 3 and 4.
Yes.
No, sorry, 3 and 6. If we insert
3
it
and
in
6.
in place of 4, we need to update 3 and 6. So, and of course, it might always be that you are on the edge case where it's the heads or the tails. So then you need to update the other pointer.
Mm-hmm. So before I set the.
You should take a copy of next and previous as you did in or the other colleague, I don't remember, in the line 113. And then you just update next and previous accordingly.
So previous.
Actually, you could copy the whole code block line 117 until
Ah, yeah, true.
28, and then and then just what you are assigning will be different than what you have here in this example. So next will be wait, so instead of previous you will be assigning previous is
I
the
think
one.
this is correct because the p-where comes before the previous, so the
true.
next one gets the next one.
That's
Then
should be
the-
right. Then this part can even go. You only need the
Yes.
second set of ifs. No, the next the whole block until 146. That
No,
was too
that's
much.
just too much.
You only need the second half of the code block, where we are assigning next.
Huh.
Because as you are right, the previous will be unchanged.
So this I don't.
No,
yeah,
no.
yeah.
This you don't.
This,
Yeah.
yeah.
And instead of
Previous p next is then the p-where.
no, that will be new entry.
What is new entry? Ah,
The one you created.
yeah. True. And what is
And-
p head?
That will be the same.
Ah.
We only have one edge case to take care of, namely when p-where would be null.
The first one.
No, when it's the first one it works,
Ah, okay.
but it doesn't work if you want to insert it after the last element. So if this is 0, then we just do the append instead of the current function. and no p data,
No,
just
no.
data, append data. If there is no where, that was correct.
Yeah.
And data is the name of the variable, not the part of the function name.
Yeah.
Oh, no. Just data, not where. Where does not exist. You cannot reference
Yeah, true. Yeah,
it, and
sorry.
then you should put it in yeah, but the return needs to be in a scope.
Yeah, I need
brackets.
brackets for this.
And the semicolon. And let's make a test case for that.
I should be able. Let's take this. At position 2.
Well, where is not position, where is a pointer, so you need to have the right pointer. This if you scroll down slightly, scroll up, stop. Here lines 245 and so on give you how to get a pointer to some position. A bit higher. You just start with get head, then you make it next until you are where you want to be.
Oh yeah. And then I can just run this again, right?
Mm-hmm.
What happens? An exception. How nice.
No, it doesn't compile. Click on one of the error messages. There it should be called p-where and not to remove.
Ah yeah, of course, yeah.
Okay, you can open the window. It's the most right one, this one. Yep, it was
Yes,
inserted.
it worked.
Great. So one more detail we could add is a two insert functions for the iterators that will then just leverage the item insert. It will be quite simple. It will be analogous to the arrays function, just that it will use that it will do insert and not return an iterator. And it takes an iterator and of course the data to be inserted. So comma t.
What type is the data again?
T reference data. No, T end symbol. Yeah, data.
Was the data of data was the first one.
Mm-hmm.
But I think it's not J++,
we
but
don't
J
need
minus, right? Because I have to insert it before.
well, technically you need to do it after you do the insertion, otherwise it will not work correctly, and it should be minus minus. And we
Yeah.
don't have a minus minus. Then let's add a minus minus operator to the iterator. To both iterators, actually.
Can you do this, please? Because I had problems with the exercise where we had to do this, and I always got an exception for an What
Sure.
was it called? Let me check the exception again.
Minus.
I always got an exception for a char being in an invalid safe location and an invalid iterator, and yeah.
Well, it should be as simple as this. Just have one problem. That is that if we iterate backwards, well, we are not usually supposed to iterate backwards. Because the thing is, we need somehow a break condition, and if we are going backwards, we will not be usually comparing with end, but we would actually, in the normal way, compare with begin. So the thing here needs a special case. That complicates things a bit. But to initialize this with head, so let's let's call this head again. Alright, so we initialize this with head. We have the copy of head, and now if we do here the where was it here, the minus minus, if this ends up null, if this ends up null, then this is equals np head. That should take care of that. Now we should be able to even insert on the first position. Let's try it out. So we get the begin, and then we want to insert e, comma 0. Should be const, I guess. Yeah. Oops. 0, 0, 2, 3. Yeah, okay, that works. Yeah, that works. Good. I think that's a good place to stop. We only have 12 minutes left anyways, and we should not start something that we will not certainly finish. So that's that. We are done. Thank you for cooperation, and we will see each other for the lecture, for the last lecture in 3 hours. So, bye bye.
Could I ask a question?
Sure.
So, could you go to the xtable file? So I had this issue with the
table.
I think. Can you scroll up? I think.
It doesn't go up anymore.
Yeah. So okay. So I think in one of the homeworks we were supposed to make this doubly linked, and then I added a to line 20 another table or another array for the tails. Now I had the issue that for some reason that then both of these arrays pointed to the same memory address. So whenever I updated the head, the tail was also set to the head. So I didn't understand how this happened. Like maybe I allocated memory wrong in the wrong way, or yeah, I'm not sure exactly.
Well, yeah. It was always the same thing. I would need to see the code to be able to say something about
Okay.
it. So
Yeah.
just like this, it's difficult.
Okay. Yeah. Well, essentially, all I did was to add another row beneath row
Mhm.
20. That was p-tails, and all
Mhm.
that array was also of length 0. And then
Yes. No, I see the problem. The way this works only if we only have one entry, because if this has length 0, then every next entry of length 0 will still point to the same memory address, because the previous element was 0 length, so the internal counter doesn't get incremented.
I see.
So if you need a second array, then you would need to make this just a pointer,
Yeah, this is what I did.
buckets 2, and then allocate with a second call to malloc an additional memory.
Yeah,
I mean, you could of course try to be smart about it and just use one malloc where you allocate size of SX table plus size of SX entry list 1 plus size of SX entry list 2, and then you set those pointers to the right offsets within your one block. But that's a minor optimization.
Yeah, I think in the end I solved it by not by changing it from a 0 length array, because I don't know. Okay, so it's because it's 0 length, so it doesn't get incremented. I see, that makes sense. Okay, thanks a lot.
Okay, and any other questions?
Yeah, just organization-wise, I was wondering when you want to like grade us and everything, because maybe if it would be okay if I until the end of the week maybe upload the last 2 exercises, because we haven't discussed them yet, but I also haven't gotten to them yet, and I think I could still find the time to do them.
I can
Would that
start.
be okay?
Yeah, it's fine. I will start the grading in first week of February, anyways.
Okay, thank you so much. All right.
Any other questions?
Clear.
Okay. If there are no more questions, then we will see each other for the lecture.
See you later.
See you.
Bye.
Bye.
See you.
See you.